Hi everyone, this is a representation of power system components. In this video, I will be explaining solving numerical on drawing the reactance diagram of a given power system. Let us consider a problem. In this problem, it is given the one line diagram of the power system, and in this we have one generator, two motors and two transformers and one transmission line, and along with the one line diagram it is also given how the individual power system components windings are connected. Example, generator, it is connected in star fashion, neutral is grounded. If you consider transformer 1, primary is delta and secondary is star, like this all the winding connections of the individual components are given, and also the each machine rating of the individual machine is given. Example, if you consider a generator is a machine and it is 300 MVA and it is 20 kV and subtransient reactance they are given 20. So like this all the component details are given in this. In this problem, it is required to find the reactance diagram from the impedance diagram, and also we have to mark the impedance values in the impedance diagram. First, I will teach you how to write the reactance diagram or the impedance diagram for a given power system. So here we have a generator. First we have to write one reference, and then let us consider a generator. Generator can be represented as source value Eg, and Xg is the reactance of the generator. So the beginning and the end of the power system, like generator and the motors, so we have to write it in parallel. So whereas in transformer 1, transformer 2 and transmission line, these three we can write it in series. So transformer 1, it is represented like this. Next transmission line, one more transformer, and then motor. These two motors, they are represented like this. So this is EM1 and this is EM2, and this is XM1, this is XM2, and this is XT1, XTL and XT2. So this is what the reactance diagram of a power system. So now the next point is to write the reactance values in per unit. So for that we have to consider the base values. First we have to consider the base values on any one part of the system. See, in the problem given, we have to draw the reactance or impedance diagram of the power system shown and mark all the impedances in per unit. Select the generator rating as base. So generator rating here they have given is 320. So that means the SB value is the base power, that is 300 MVA. Always SB is in MVA and VB is the base voltage. This is always in kV. This is always in kV. That is 20 kV is given. So now after knowing this, let us mark the different parts of the power system. So as I told you in the previous pre-class videos, a transformer divides the whole power system into two parts. Suppose if you have in this problem we have considered two winding transformers, therefore this power system is having three parts. I will mark the three parts here. So this is these are the three parts. This is motor side one part and transmission line side one part, and we have generator side one part. So generator side base voltage is already given, that is 20, and base voltage on the transmission line side and base voltage on the motor side it is required to find. So let us have the formula to find the base voltages. Base voltage on LT side of transformer if you want. So transformer 1, LT side of transformer. See here we want HT side because this is generator transformer, this is LT, this is HT, because generator side transformer function is to step up the voltage. Load side, the motor side transformer is T2, its function is to step down the voltage. So, this is HV winding, this is HV winding. So, high voltage side is transmission line side. So, it is required to find the HT side of transformer 1, HT side of transformer 1 base voltage, this is. So, to find that, what we do is, formula is base voltage on LT side of transformer 1 into HT side voltage rating divided by LT side voltage rating of the rating of transformer 1. So, that means base voltage on LT side of transformer 1, this is LT is VB is known, that is 20 kV, let us write all in kV. Next, HT side of this transformer 1 is and transformer 2, the problem here is transformer 1 is of 3 phase rating clearly given 350 230 bar 20 clearly given. Transformer 2 is made up of 3 single phase units. So, the power is multiplied by 3, that is 300, and here we have to see the winding connections. So, let us write the voltages here. Transformer 1 is 230 bar 20, actually it is LT side is 20, this is 230. Next, here we have 127 bar 13.2, LT side is 13.2. So, let us see the windings. See here, this is star, therefore 127 you should multiply it by root 3, 127 you should multiply it by root 3, because star side, no, therefore. So, then 127 into root 3 divided by 13.2, that is delta. So, line voltage and phase voltages are same, therefore 13.2 we have to consider, 13.2. So, now let us write the HT side voltage rating of the transformer 1. HT side is 127 into root 3 divided by LT side voltage is 13.2. So, this is the answer for the base voltage on HT side of transformer 1, that is this. So, next in the same lines we can write base voltage on LT side of transformer, So, that can be find by having the next slide. So, here base voltage see here base voltage on LT side of transformer 2, if you want base voltage on HT side of transformer 2 into LT side voltage rating divided by HT side voltage rating of transformer 2. If you see the previous slide, so it is calculated if you see the previous slide, it is calculated that the base voltage on the HT side of transformer 1 is this is, let us consider see voltage 1, this value V1, let us consider V1. So, here V1 into actually this value we can write it as if we calculate in the calculator, it is V1. So, next this V1 into LT side voltage rating divided by HT side voltage rating. See here HT side voltage rating is 127 into root 3, 127 into root 3 divided by LT side divided by HT side. So, HT side is HT side this will arise LT side is 13.2 divided by HT side is 127 into root 3, 127 into root 3. So, V1 value is known. So, you can find the base voltage on, so let it be V2. So, this is how we can find the base voltage on different parts of the power system. So, after calculating the base voltages, one can find the reactance values. So, example, if I want to find the generator in per unit, if you want Xg per unit base value, if you want rated value into SB by SR into VR by VB whole square. So, here what is the rating of the transformer reactance, that is 20%. So, 20% means 0.2 into SB. SB remains same for the whole system, that is 300 divided by what is the generator 1 rating, that is also 300. So, 300 VR by VB. VR value is voltage rating is 20 kV. So, 20 kV, base is also 20. So, this value is 0.2 per unit. That means, whichever the component whose value are taken as base values, then the per unit value on common base will be the given value. This is how we can do, and we can find in the same lines the X per unit on common base for transformer 1 is X per unit on rating of transformer 1, same formula SP by SR into VR by VB whole square, same formula. So, the given value of transformer 1 is 10%. So, here 10% means 0.1. SB we have taken it as 300 divided by SR, that is transformer 1 rating is 350 into VR transformer 1. Here very important is transformer is having two voltages, one is LV side and HV side. Suppose if you take LV side rating, we have to consider the LV side only. So, LV side voltage rating is how much? 20. So, it is 20 divided by base is generator side, LV side is also 20. See here it is found 20, it is given 20. So, like this we can find the value of X per unit on the transformer 1. Similarly, you can write the transformer 2. Transformer 2 also in the same formula, that is X per unit on common base for transmission lines, let us write. So, this is actual value divided by base value, actual value divided by base value. What is the actual value? See here transmission line is having 64 kilometer long, is having 0.5 ohms per kilometer, that is 64 kilometer long. The value of reactance is 0.5 ohms per kilometer, 0.5 ohms per kilometer. How many kilometer? 64 kilometer. So, kilometer get cancelled, you will get the actual value. Base value is ZB, formula is VB square by SB. So, here the transmission line side base voltage, it is already found, that value we have to consider, that is, let us take V1. So, V1 square by SB is always same, that is 300, we should consider 300. So, this is how you can find the base value. This base value you write here, and you can find the value of X per unit on common base for transmission line in per unit. Actual value divided by base value. So, you will get ohms get cancelled, you will get per unit value. So, this is how we can find the value of x per unit on the transmission line. Similarly, one can find the generator motors also, motor reactance also in the same lines you can find. So, I will tell how to calculate the transformer 2. So, in the same lines, transformer 2 also you can calculate. Transformer 2 x per unit on common base for transformer 2 is equal to x per unit on the rated value into SB by SR rated value, SB by SR into VR by VB whole square, same formula. So, x per unit on the common base, the transformer, that is 10%, it is given. So, 0.1, SB is already it is known 300, right, 300, SR value here 300, okay, we have converted into 3 phase, that is 300 into VR. So, let us consider transmission line side only. So, that is rated value is 127 into root 3. 127 into root 3 divided by base value on transmission line side, it is found, okay, we have to consider that and calculate the value in per unit. This is how we can find the per unit value of transformer 2 reactance. Similarly, we can find the motor side. So, the motor side also you can find the same formula. So, only thing here I will change is motor. I will put this one is motor 1. So, motor 1 actual value of motor 1. So, here motor 1 is 20% and it is 200 clearly given 20%. So, 20% is 0.2 into SB 300. So, what is the rating of the motor that is 200. So, 200 into VR by VB. What is the rated voltage of motor? That is motor 1 is 13.2 and base value in the motor side it is found. So, that motor 2 side let us be V2. So, you can use this formula to find the motor 1. Similarly, motor 2 also in the same lines you can find. So, by knowing these reactances for generator, transformer 1 and 2, transmission line and motor 1, motor 2. So, you can mark the values here. This is how one can find the reactance diagram of a given power system. So, they are asked here the impedance diagram. So, if you neglect the resistances in the impedance diagram, you will be getting the reactance diagram, because in this problem it is clearly seeing here they are not given the reactances. You can see this problem. So, they are not given any resistances. If you are not given any resistances, one cannot find the resistance values. So, even though it is asked here the impedance diagram, since there is no resistances are given, except there is no resistances in all the component, no resistances, you can write the reactance diagram itself as the impedance diagram. So next you can see this problem, that is the second problem on this one line diagram. So here the one line diagram of an unloaded power system as shown in this figure. The generator and transformer ratings are as follows here. So here this problem is almost same as the previous. Generator rating is given, generator 2 rating, generator 3, it is clearly given, generator 1, generator 2, generator 3. Transformer 1 is also no problem, it is given on 3 phase. Transformer 3 is also no problem, transformer 3 is also no problem, it is given on 3 phase. Transformer 1, transmission line 1, transmission line 2 and transmission line 2, two transmission lines are there, its values are also given. So their transformer 2, it is made up of 3 single phase units, each one is rated of this much. So we have to convert it into 3 phase. Transformer 2 we have to convert it into 3 phase. So power is 10 multiplied by 3, it is 3 phase, no, it is 30 MVA it becomes. Then reactance you should not change, let it be 10%, it is per phase only. Next the voltage 127 bar 18. So you have to see transformer 2, its windings are here HV, LV and this is HV, because it is towards the generator, it is towards the generator side. Therefore, we have to consider the LV winding, HV winding in this pattern only. And you can see the voltage is 127 bar 18. So 18 is low and here 127 bar 18 kV it is given. Now if you see this properly, then LV side is 18 kV, it is delta, and star side is HV, it is HV. Therefore, whenever they have star, then we should multiply with root 3 in order to get on 3 phase rating it is. So now the voltage is 127 into root 3 bar 18 kV. So this is the 3 phase rating of the transformer 2. So here they are asked us to find the reactance diagram with all the reactances marked in per unit on this base generator side. So generator side base voltage is given, that is the 13.8 kV is given, generator side is given. And here if you see the power system, we have totally 3 transformers. If you see this properly, 3 transformers here we have. So we have to make the different parts here, we have to make it different parts. So how to make it different parts? Transformers will divide the whole circuit into 2 parts. See here, this is one part, okay. Then from transformer side, this is the second part, and here we have a third part, and then from here to here, and then from here till here. So this is one part. So totally how many parts? This is part 1, this is part 2, this is part 3, and this is part 4. So here base voltage in first part they are given, and it is required to find the base voltage on the second part, base voltage on third part, and base voltage on the fourth part. So how to find the base voltage on the second, third and fourth part? It is clearly told in the beginning of this presentation. So I will tell you once again, base voltage, this is generator side always LV side, and this is HV side, generator side this is LV side, and this is HT side. So here it is required to find base voltage on HT side of transformer 1. Okay, that is given by the LV side transformer 1 we know, and if it is written LV, this is you should write HV divided by LV voltage rating of transformer 1. So same as I discussed previously, the same lines you can find. So base voltage on LV side is 13.8 into voltage rating of transformer 1. Transformer 1 voltage rating you see. So HT side is 220 divided by LV side is 13.8. This get cancelled, you will get 220 kV. So here you will get 220 kV. Similarly, you can find the base voltage on transformer 2. Base voltage on LV side of transformer 2. Here this transformer, this base voltage on this part I am finding. So, for this the previous is 220 into voltage rating of transformer 2. Transformer 2, it is found on 3 phase, okay, in the explanation, that is 127 into root 3 upon 18. So, always these numerator and denominator terms should be almost in the same range. So, this is how you can find the base voltage on third part. Similarly, you can find the base voltage on the fourth part. So, likewise you can complete the problem by knowing the base voltages in different parts. By using the same formula to find the reactance on common base, you can find the values. So, this is problem is same as the previous beginning of the slide I explained, no, the first problem, it is same. With this I will be ending this video.